This lesson comes from section 6.4, solving trig equations using identities. The example asks us to solve for all the answers between 0 and 2 pi this equation, sine 2x minus cos x equals 0. Two problems just looking at it as is. I've got a double angle and a single angle, which is an issue, and I also have sine and cosine. So my first thought is, let's get rid of the double angle problem. Look at your formula sheet and you'll realize that sine 2x is 2 sine x cos x. And you've got minus cos x equals 0. Now one quick factoring step, and I'm able to actually separate the sine from the cosine in this question, because if I factor out cos x as a common factor, I've got 2 sine x minus 1 equals 0. Now it's all factored and equal to 0, which means I'm really solving two little equations. What makes cos x equals 0? That would make that equation true. Or what makes 2 sine x minus 1 equals 0? So what does make cosine x equals 0? If I remind myself of my unit circle, I've got a couple places there. Pi over 2 and 3 pi over 2. Between 0 and 2 pi, that's all the answers that I have. What makes 2 sine x minus 1 equals 0? That's if 2 sine x equals 1, which means sine x equals 1/2. So again, nice unit circle number. Sine x is positive in quadrants 1 and 2, and specifically at pi over 6 and 5 pi over 6, sine x is equal to 1/2. So the answers to this are those four answers. And if you wanted to list them as one set of solutions in order, you'd say, pi over 6, pi over 2, 5 pi over 6, 3 pi over 2 are the four solutions to this particular equation. If you were going to solve this thing graphically, like if this is a multiple choice question and you're more confident that your graphing calculator is going to do this than you are, you would just start off by graphing, and you might take your equation and say, let's make sine 2x equal cos x. Graph one side of that, y1 equals sine 2x. Graph the other side of that, y2 equals cos x, and graph it for windows between 0 to 2 pi, or slightly bigger maybe, and you're going to have a regular cosine graph, which looks like something like this, and you'll have a sine graph that's been stretched horizontally by a factor of 1/2, and so it's going to go up and back down, back up, not the nicest drawing you've ever seen in your life, but you should find 1, 2, 3, 4 intersections. And as mediocre as the drawing is, you can see even roughly where those intersections are. So you'd press second, trace, intersect, and that would be the most important part if you were showing this on a quiz or something. Intersect, and you get the answers. Now, doing these in radians, you're not going to get exact value answers. You're going to get pi divided by 6, which is a terrible looking decimal, pi over 2, which is another one, 5 pi over 6, etc. I would suggest you actually maybe graph this in degrees, 360 degrees. You'll get answers like 30 degrees and 90 degrees, 150 degrees, and 270 degrees, and then it is easy to change those into radians using exact values and get the answers you're looking for. So it depends on how this question is asked, what you're forced to do. If they say solve it algebraically, you need to use the identity and do it the way we did at the beginning. If they say solve it graphically, this would be a good graphical solution at the bottom. And I do suggest graphing it in degrees and converting your answers to radians so that you can stick with exact values instead of giving answers like 1.57 something 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 radians as an answer.